This is just a brief intro of what I do and where I work. So the primarily the overview of it will be divided into mostly understanding of the part that what unlearning is, uh, why we came here and how we arrived here at this stage. That with the recent development, with also the recent cost, security breaches, everything, and then how our unlearning frameworks are developed, or what things needs to be considered while uh, building something, or while deciding any forget making any systems, forgetting certain things, how to evaluate such systems, how to test them. So evaluate in the sense that the same evaluation criteria we normally use in any ML algorithms, the same evaluation criteria and a lot more on top of that. And then there comes the verification, in the sense that what the things that we made the model unlearn, is it actually unlearned, or is just there, it's not showing, something like that. So that two parts of the verification part also be explored here. So the first question that comes into mind, that why we came here, why we need to do, why we not cannot just retrain, why we need our learning, or in the first sense, why we need our learning in the first sense at all. So the first thing is the privacy part. I just included one portion for the Facebook privacy policy change, just for understanding of what happened and why. Same included the iCloud photo, the hacking part scenario itself. And then the came the right to be forgotten regulations, as well as the multiple regulations, including in FTC rulings, recent FTC rulings, as well as the GDPR rule, uh, uh, GDPR provisions, as well as the proposed Canadian law provision as well, on the same part, that uh, certain elements, certain informations is cannot be just be deleted from the databases, cannot be just deleted from stored data storage systems, but the influence of those items, the influence of those systems has to be also deleted from the products that the companies are selling as well. Because our data is not just our data which just merely sits on on a hard drive somewhere. It is actively being trained on, the inferences intelligence is actively being extracted from, and then new business development, business ventures have been getting developed from there. So that, but the last part, that the data is not just mere data itself, that is where the right to be forgotten regulations came into picture. And the need for unlearning, or making things forgetful, or making machines forgetting informations, became much more paramount. Second part is security. Obviously it is security, but the security is not just privacy related security, but security is related to the robustness of the model itself. Because we have seen certain injection based attacks on the certain models, on certain systems itself, including spam filters, and even simple polygraph, simple worm detection algorithm itself. So the idea that uh, a certain bits and pieces of information, certain bits and pieces of sample of records can be introduced, can be injected, and the underlying base model can be corrupted, has been quite frequently published, has quite frequently referenced as well. So the security part became very much prominent in the whole conversation on the uh, model for forgetfulness and the unlearning of the model. And third part is the usability. So for example, consider the recommendation system, or like any recommendation engine, be it Spotify, Netflix, or anything. I think most of people who have joined has experienced that if you lend your account of Netflix to someone else's, and they watch some weird shows, your Netflix recommendation gets messed up. So that also comes into picture in the same part itself, that how to retrain it, how to make the things much more forgetful. And the second part is the same conversation, is why unlearning, why not just retrain it? I mean, if you just retrain it, it will be much more easier, much less headache. So the next part is that cost associated to anything related to any production grade systems. So I just added one cost on how to on cost related to training large parameter models, So on the right side, on the graph itself, you can see the pictorial representation that how the cost has like almost linearly and then exponentially shoots up. So you cannot just untrain retrain a model just at the whims of some at the whims of an click. So there are specific costs associated with it, which makes the whole process very cumbersome, as well as business wise quite costly. So that is when the unlearning part comes into picture. So uh, the current research space as such how we came here is not new, in the sense that it's not just now that people started working on that. People has been started working on that for a long period of time. So the initial decremental based learning systems were there like 2003 2004, which were primarily for kernel based or svm based models. Then the traditional machine learning term was introduced, I think, in 2015. So that paper that paper gave an understanding of what machine learning is, what certain paradigms to treat, and then and then the basic framework of that. Then we went to 2019, which introduced some probabilistic feature into the whole learning paradigm itself. And continuing from that, that same probabilistic nature had then theoretical error boundedness into the model framework to make people understand, to make people some give people some understanding of the theoretical error boundedness of all of any learning framework. And till now, till I think till this paper itself, till this stage itself, most of the work has been done on linear models or logistical regression models. Very few work was done on deep learning models itself, but that also started changing, I think, from from papers, I think, from starting from 2020 itself. So a couple of papers, couple of really good papers I have referenced here. If anyone wants to go through them, just to see how the space evolved, how where we started from, and how we came at this stage, this would give a brief understanding to them just by reading a couple of the following this timeline, how we arrived at this stage. So the first part that comes is the challenges. What are the challenges that normally developers or researchers faced while looking into the paradigms of the learning frameworks or any ML learning frameworks? How uh, what kind of things they need to encounter, what kind of things they need to take care of, something like that. So first thing that comes into mind is the stochasticity, because any ML algorithms is stochastic is nature. So the training process is also becomes stochastics in nature, in the sense that when you train a model, you just don't train it for one single batch. The data sample is not from one batch, it is present in multiple subsamples, multiple sub batches as well. So how to remove influences of all those of that single instance from all those batches, that is the one of the biggest headaches. Then comes the incrementality part of the system, that the specific items, there are specific samples which is being asked to be forgotten, influences which is coming after it, and it is also being influenced which is coming before it. So that incrementality part, that the smooth linear flow also gets broken if you just pick something up then throw it away. So that also is one of the biggest headaches. These two are one of the biggest headaches while in building any kind of learning frameworks itself. The third one is the catastrophic unlearning, in the sense that you can just unlearn a model, but at the end of the day, if the model doesn't perform well, if it's absolutely bad, in the sense the accuracy part, anything, then there is no point of building those unlearning models itself, the framework itself. You can just retrain it, and because business wise, you need that system itself in place. But the unlearning part made the system so unusable that the accuracy is so low that it is not service it is not filling the promises of the business use case. So that is the last part of the unlearning accuracy or catastrophic nature of the learning process, that it can go bad, and sometimes it can go terribly bad from the model performance robustness itself. So the general framework of unlearning model, or making a system forget something, is somewhat starts with a pre-trained model, where the model which has already been developed, either proprietary or in-house trained or something like that. There is a specific training data set. I can be very specific to domain specific, or can be very general purpose, but there is a training data set. But then you have the unlearning part introduced, where is you have a forget data set, where might be a single sample needs to be forgotten from the from the data set, might be a class of sample, might be a feature set, something like that. And then there comes the evaluation metrics part, that how would you determine that the model that you have, the unlearned model, is it good enough? Is it good enough to be redeployed again? Is it good enough comparing to the previous one? How good enough it is? And the second and the foremost part is, how long does it take, like the whole efficiency part. How long does it take to unlearn it? Does it make sense to just retrain the model itself if it is taking too long to unlearn it? So this is the basic framework how an unlearning, how a normal forgetful systems move around. So the design requirements of the previous or the previous diagram corresponds to or translates to three different parameters that everyone looks at, or everyone takes care while developing something. So first is the completeness. So so the prediction that the system is making, how good the predictions are compared to the previous one, in the sense that if it is simple if it's a simple uh, a simple binary classifier, image based classifier, how good the systems is compared to when the system was full, in the sense that there is no learning there is no systems data were not removed, or something like that. That constitutes the completeness. And if possible, how worse it is also compared to if you had just retrained the model itself. So these two things, two parts, accuracy wise, constitutes the whole completeness part of the paradigm, that how complete is the unlearned model. Is it worse, is it better, or is it somewhat considerable? Then the timeliness part, in the sense that same if efficiency parts comes into picture, that how long does it take to finish it. It might take a couple of minutes, it might take more than the time that it actually took to develop the model. So actually train the in actually took to train the first model itself. So the timeliness comes into the picture, because at the end of the day the system needs to be efficient, while if any production system needs to be efficient, and the process, the MLOps part itself also needs to be efficient, so that the systems or the ML models are deployed quickly, uh, given certain business requirements or use cases itself. And then the third part is the verifiability. For say you have, there is a learning, for say considering this diagram itself, there is a model already there. The model that certain data sets has certain samples has been removed, the influences has been removed, but is it actually removed? Is it verifiable? How much how can you verify those certain things? So that is the part. These three are the primary it's like a triangle part, that these three are the primary cornerstones while designing any learning framework. So these are the primary design elements. Then comes into the picture that the what kind of removal request, or what kind of removal can be done. So if I go back to the initial slide itself, you can see the forget data set can be single sample. uh, I mentioned here item wise, just a single sample from the data set. It can be a feature. So for say consider a scenario where it has been noticed that the certain feature of a model, for simplicity purposes, consider a classify itself, spam filter itself, email spam filter itself, consider a certain feature wise, that if a certain feature needs to be needs to be removed, or the influence of certain features needs to be forget, then how do you take that request into into the whole conversation itself? Because when you talk about features, you have to talk about whole whole data set itself. So whole training set itself, whole validation set itself, whole testing set itself. So that feature wise classification, that feature wise removal is one of the trickiest part while considering this kind of scenarios. And then the class wise, so if you are considering any kind of, if you are encountering any kind of situation where you have to look for biases, you have to look for certain biases related to gender, race, something like that, then also this class wise removal is one of the most important removal types, in that sense that you want to remove certain class from the whole data set, from certain class from the training data set, something like that. So that class wise unlearning or class wise removal becomes one of the largest becomes one of the most frequent removal requests, in fact, on whole production scale, not just individual scale itself. In most cases the individual scale, the item wise removal is most of the times that is noticed. Then the comes part in the verification and evaluation phase. So this is the part that I mentioned in the and the last phase, that once you have the learned model, how do you evaluate that model is good, is it good enough, the model actually will perform, or even whatever unlearning happen, or the machine system actually forgot, is it did it actually forget, or it is just false positives. So I just added most of the used methods for verification and evaluation metrics. I'll not go through all single one of them. I just pick two from verification and evaluation. So if you just look at the evaluation metrics, it is the same accuracy, learning time, same kind of metrics that you use, but then a lot more is added on top of that, considering the kind of evaluation that you are trying to do is not just determining if the model is good enough or not, or if the model is trying to predict good enough or not. That is just one, at least 10% of the whole part. Then the comes into the picture, that how long it takes, what is the completeness, how good it is, or in the sense that if you have changed, for say if the model has changed, if it's a deep neural network, how the weights change over time. So something like that. So the evaluation metrics also changes quite drastically. And the verification part is not verifying is the model performance itself. The verification part is verifying is the model actually forgot what it's supposed to forget. So it is not indication of the how good the model is, but rather how robust the model is. So I'll just pick two verification method from here and two from evaluation metrics. So the first one is the feature injection set test. So where you so I actually added the paper as well when it was where it was first reference first mentioned. So two of the most useful or use cases are first is the feature injection set, where you add a feature set which has very high correlation, or more specifically direct correlation with the with the samples which is supposed to be forgotten, and very minimal, almost tends to zero correlation to the rest of the data set. So what will happen is uh, you will see the change in weight quite drastically, while change in weight quite drastically if you introduce a single feature for all the samples, where the correlation of the feature is quite high for the set that is supposed to be forgotten. So the weights so the model weights supposed to change, in the sense that not supposed to change, model weight will change quite drastically. And if you just plot them before and after, you can see that the weights has actually changed. And then you get some understanding or some indication that the system is performing differently, considering that the metrics, the accuracy metrics are still okay, are still acceptable. Then you have the verifiability of the model, that okay, the model is actually have forgotten what it was supposed to forget. And next, then I think this is one of the one of the most talked about adversarial attacks as well. So the membership inference attack. So this is where the model this is primarily for the usefulness of the model itself, where the model supposed to forget certain records, and the change in weights between the layers has changed. So that is where the membership inference attacks comes into picture. The I think okay. So the last one is almost done. So last one is the evaluation metric. So what kind of evaluation metrics is used to determine if the model is good enough or not? In the sense that, is it usable or not? It has nothing to do with the verifiability of the model. It has nothing to do with to determining if the model has actually forgotten or not. It's just to determine the model's performance. I am not explaining the other parts that I mentioned here: accuracy, uh, and inversion attacks, zero source, everything. I just adding two parts, two metrics, which is different than the other, which is different than the other normal machine learning development parts itself. So the layer wise difference distance. So this is where the distance between the weights between the layers changes quite drastically to make the model indistinguishable among each other. The evaluation metrics, the accuracy might be same, but the layer wise distance, or the Jacquard distance between the layers are are so different that the models are indistinguishable between each other, considering that everything else has worked, considering everything else is identical. So this gives a this gives a robust understanding if the model has actually is different than the previous one, or is it just a simple one, simple same probability, same everything as the other earlier one. So this layer wise distance, the layer distance between the layer, the weights and the Jacquard distance, it gives a pretty good understanding, a pretty good difference for that. And the second one is the unlearn time. So you might have built uh, a robust framework with a good evaluation metrics is in place uh, to understand if the model is performing well or not, and then to understand if to actually have an understanding of the verifiability of the model also. But if it is taking too long time, then the efficiency will come into picture, that how long the model is taking, the how long it is taking to unlearn. Then if it's actually taking more time, then it will be just economical to just retrain the model at all. Like, why would you unlearn it when you why would you build something to unlearn a model if it takes taking too long? So these two parts targets two specific dimension, to specific scope of the development. One is the distinguishability between the two models, in the sense the model previously and the after the model forgot. So the first one targets the distinguishability between them, and the second one targets the efficiency. Is it actually viable to unlearn the model or to build the framework itself? So this is a, very brief understanding of a brief overview of the whole machine learning paradigm. There are much more things in there, the whole learning algorithms, how to define them, how to even define metrics itself. I couldn't go, I think almost out of time, couldn't go over them. uh, yeah, I added almost all of the references in the slide itself. Yeah, that's it. Thank you.